Hi friends, today I am giving a lecture on algorithm for sum of subsets problem in design and analysis of algorithms. Before going to the sum of subsets problem algorithm, we have to discuss about some parameters. These parameters that can be passed as parameters for sum of subsets problem. Okay, so before going to discuss about these parameters, first we have to observe one example problem. By using this example, we have to find out the solutions. Okay, how to find out these solutions? So in that algorithm, to understand that, we have to use this example. Okay, so let us consider this example. Let n is equal to 6. So that is nothing but number of object weights is equal to 6, m is equal to 30, and weight vector w of 1 to n, here n value is equal to 6. W of 1 to 6 is equal to set of weights of 6 objects, that is 5, 10, 12, 13, 15, 18. Okay, our main objective is we have to take some subsets from the weight vector whose sum is equal to capital M, that is 30. For example, we have to take 5, 10, 15. This is one subset. By summing these three object weights, it is equal to capital M. So 5 plus 10, that is 15. 15 plus 15, that is 30. So one solution is 5, 10, 15. Next, we can take another solution, 5, 12, 13. Okay, 5 plus 12, 17, 17 plus 13, that is 30. So this is another solution, 5, 12, 13. Okay, so our main objective is we have to find out all the subsets of weight vector whose sum is equal to capital M. This is our main problem. Okay, next here to solve this problem, we have to use this rule. Here sigma wi xi, that is the sum of the product of the weight vector and solution vector. Okay, so that means here what is xi? Xi is nothing but an instance of the solution vector. So that is x of 1 to k is the solution vector. It consists of x1 comma x2 comma up to xk. Here each xi value, it can take either 0 value or 1 value. So for example, this one, x1 is equal to 1, we have to consider the weight 1. x1 is equal to 0, we have not considered the first object weight. Okay, so here this is the solution vector. This solution vector can contain either 0 value or 1 value in the weight vector. So suppose x1 is equal to 1, the first object weight is considered. x1 is equal to 0, the first object weight is not considered. In the same way, x suffix k is equal to 1 means kth object weight is considered. X suffix k is equal to 0, kth object weight is not considered. Here sigma wi xi is nothing but sum of the product of the weight vector and its solution vector. Okay, k is the weight number in the weight vector, position of the weight in the weight vector. Sigma wi is nothing but sum of the weights in the weight vector. Okay, so this is the sigma wi xi, k sigma wi. X suffix k is equal to 1 means we have to consider the kth object weight. Suppose kth object weight is considered in the weight vector. So this is the rule we have to follow. Sigma wi xi plus here we have to take kth object. Kth object weight is w suffix k. Okay. Here this is sigma wi xi plus this is kth object weight because we have to consider the kth object. Okay, comma k plus 1. This is the position of the next weight vector. Position of the weight in the weight vector. Next weight vector. Sigma wi minus wk. Here the total weights in the weight vector is denoted by sigma wi. From that one we have to subtract the weight of the kth object. Okay. Next, the right children, x suffix k is equal to 0. This is the left child and this is the right child. Left child is nothing but x suffix k is equal to 1. We have to consider the kth object. Okay. Here x suffix k is equal to 0. We do not consider the kth object. At that time, if we do not consider the kth object, so it is not changed sigma wi xi, comma. Next one is this k plus 1 sigma wi minus wk. Here this is same. Okay, only the first term is changed. Here we have to consider the kth object. So then we have to sum the w suffix k to the sigma wi xi. Okay. Here we do not consider the kth object, so then we do not subtract the kth object weight. So sigma wi xi, comma k plus 1 sigma wi minus wk. So by using this rule, we have to find out all the solutions by using state space tree for a given sum of subsets problem. Okay. Next, here this one. Here initially we do not consider any object, so sigma wi xi value is equal to 0. Next, so here position of the weight in the weight vector, so the weight vector starts with 1, so that is k is the index of the weight in the weight vector. We do not consider any weight, so first we are started with the index value, that is 1. Okay. So 73 is nothing but sum of the weights in the weight vector. 5 plus 10, 10 plus 12, 12 plus 13, 13 plus 15, 15 plus 18. That is 73. Before considering any weight, sigma wi xi is equal to 0. K is the index of the weight in the weight vector. So the starting index is 1. 73 is nothing but sum of the weights in the weight vector, that is 5 plus 10 plus 12 plus 13 plus 15 plus 18. So that is 0, 1, 73. Okay. Suppose first object is considered. First object weight is 5. Here 0 plus 5, that is equal to 5. Because why we are adding 5? Here we are considering the first object weight. First object weight is 5. So 0 plus 5, that is 5, comma, incrementing the index value after considering the first object weight, then increment the index value, that is 10. So the index value of 10 is 2. So 1 is incremented to 2. After considering the first object weight, so total weight minus first object weight, that is 68. So 0 plus 5, that is 5, incrementing the index value to 73 minus 5, that is 68. This is the left child. And the right child is, we do not considering the first object weight, that is 0 is the same. Next two parameters are same. So 2 comma 68. In this way, we have to extending the state space tree by considering all the objects. Okay, suppose this sum value exceeding the capacity capital M, then by using the bounding functions, we have to kill the node. We have to kill the live node. Okay. After all objects are completed, so this weight is less than 30, then we have to use the bounding functions, so that node cannot be extended because all the weights are completed, so there are no weights we have to assign. At that time we have to use the bounding functions to kill that live node. Okay, when will you stop the extending of that node? So here the sum of the weights is equal to capital M. So then we have to stop the extending of that node. That node becomes the answer node. Answer node. Next one. So this is the algorithm. Algorithm sum of subsets S comma K comma R. What is S value? S is nothing but sum of the product of the weight and its solution vector. Okay. So initially S value is equal to 0. Okay. K is nothing but index of the weight in the weight vector. Initially K is equal to 1. It is incremented to up to n value. Next R is equal to sum of the weights in the weight vector. So that is 5 plus 10 plus 12 plus 13 plus 15 plus 18. That is equal to 73. Okay. Now we have to find out the solution vector x of 1 to k. Among these weights in the weight vector, which weights we have to consider? Which weights we have to consider? Okay. If the weight is considered, its value is 1. If the weight is not considered, its value is 0. Okay. Whatever the weights we have to consider, sum of those weights is equal to capital M. Okay. Next, find out all subsets of W of 1 to n. We have to find out the subsets of weights in the weight vector starting from 1 and ending with n. That sum is equal to capital M. Here capital M is M. The values of xj. Now we have to find out the x of j values. Here x of k values. Okay. If the weight is considered, its value is 1. If the weight is not considered, its value is 0. We have to find out the x of j values. So that are 1 less than or equal to j less than or equal to k have already been determined. Here this is S formula. So here we have to discuss that. So product of the weights and the solution vector values, and R is equal to sum of the weights in the weight vector. Okay. It is assumed that W of 1 less than or equal to M. Here W of 1 is 5. 5 less than or equal to 30. Condition true. And sigma I is equal to 1 to n, W of I greater than or equal to M. So sum of all these weights is always greater than or equal to 30. Here what is the sum? 5 plus 10 plus 12 plus 13 plus 15 plus 18, that is 73. 73 greater than or equal to M. M value is 30. Okay. Whatever the weights in the weight vector, the sum of those weights is always greater than or equal to capital M, and weight of the first object is always less than or equal to capital M. Okay. Next, brace begin. First one, generate the left child. How will you generate the left child? Suppose first object weight is considered x suffix k is equal to x1 is equal to 1. Suppose we have to take the kth object. If we are considering the kth object, then it can be represented by x of k is equal to 1. X of k is equal to 1 means we have to consider the kth object weight in the weight vector. Then it becomes the value 1. Okay. If S plus W of k is equal to M. Here we have to considering the kth object, its weight is W of k plus initially S value is sigma j is equal to 1 to k minus 1 W of j into x of j. Okay, S value is J is equal to 1 to K minus 1, product of weight and the X of J. So this value plus weight of the kth object, that is W of K, is equal to M. Okay, so then write X of 1 to K. So whenever the sum of the weights in the weight vector is equal to capital M, so then it becomes the solution. It becomes the subset. That subset becomes the solution vector. So whenever S plus W of K is equal to M, initially Wi xi is equal to 0 plus W of K is nothing but weight of the kth object. So the sum of those components is equal to capital M. So then write the solution vector X of 1 to K. Okay, here this is one solution. So one solution is nothing but one subset. Okay, else if suppose the S plus W of K is equal to M, this is not true, then we go for else. Else if S plus W of K plus W of K plus 1. Here we have to consider the kth object weight. Next incremented value is W of K plus 1th object weight. K plus 1th object weight plus kth object weight plus S. Okay, sum of these three components is less than or equal to M. Okay, here we are considering the kth object and K plus 1th object plus initial S value. The sum of those components always less than or equal to capital M. So then sum of subsets, this is the recursive call, S plus W of K comma K plus 1 comma R minus W of K. So this is nothing but this value. Okay, S plus W of K, S plus S value 0, xk is equal to 1. So 0 plus x1 is equal to 1 is nothing but 5. S plus W of K is equal to 0 plus first object weight, that is 5. 0 plus 5, that is 5, comma K plus 1, that is 1 plus 1, that is 2, comma R minus W of K. R value 73. 73 minus first object weight, that is 5. 73 minus 5, that is 68. So this is the recursive call. Okay. Next we are considering another object, S plus W of K plus W of K plus 1 plus W of K plus 2 less than or equal to M. So sum of subsets S plus W of K plus W of K plus 1 comma K plus 2 comma R minus W of K plus 1. Okay. So this is the recursive call until this condition is failed. Okay. Once it is failed, so we have to use the bounding function to kill that node. Okay. Next, generate the right child and evaluate BK. Here BK is nothing but bounding function. Okay. When we are using the bounding function, if S plus R minus WK greater than or equal to M. Okay. Here S is nothing but sigma W of J into X of J plus R is nothing but W of sum of the weights in the weight vector minus W of K greater than or equal to M. Okay. So sum of those weights in the subset, if it exceeds the value greater than M and S plus W of K plus 1 less than or equal to M. Okay. Suppose we have to use the weights kth object, K plus 1 object, K plus 2 objects. Sum of those weights is always less than or equal to M. So in both cases, we have to use the bounding functions. Okay. When we are using the bounding function x suffix k is equal to 0, we do not considering the kth object. Then it becomes x suffix k is equal to 0. So then if it is not considered, then the recursive call sum of subsets S comma K plus 1 comma R minus WK. So these two terms are not changed. K plus 1 comma R minus WK. Here k plus 1 comma, this value is r minus wk. Here k plus 1 comma, r minus wk. So this term is not changed and this term is also not changed. Here k plus 1, here k plus 1. This is the left child and this is the right child. So now this is the right child. Whenever we are going to the right child, x suffix k is equal to 0. So then sum of subset here S value. S value we do not consider the addition of that weight object, weight of the kth object. Here sigma wi xi plus wk. So this is for right child. Left child s plus w of k. This is for left child. Right child there is no addition of plus wk. So here there is no addition of w suffix k. Okay. Here the difference is, here this is s plus w of k for left child. So only wi xi, that is nothing but s. Only s. This is for right child. Okay. So whenever we are adding the kth object weight, then s plus wk becomes the left child. When we are not considering the weight of the kth object, then it is a s. S comma k plus 1 comma r minus w suffix k. So this is for left child and this is for right child. Whenever s plus w of k is equal to m, then write x of 1 to k. Which object weights are considered, which object weights are not considered. So this is, in that one, the solution vector we are getting. So this is the solution vector. So examples for solution vectors are 5 comma 10 comma 15. So 5 plus 10 plus 15, that is equal to 30. Next one, 5 comma 12 comma 13. So that is also 30. This is another solution. Next one, 12 comma 18. So this is another solution. 12 plus 8. So these are the solutions for this given problem. So this can be written as x of 1 to k is equal to, here first object weight is considered, that is 1. Second object weight is considered, that is 1. And third object we do not consider. Fourth object we do not consider. Fifth object we are consider. Sixth object we do not consider. This is one solution. This is the first solution. Okay. Next, x of 1 to 6 is equal to, first object weight is considered. Second object weight is not considered. Third object weight is considered. Fourth object weight is considered. Fifth and sixth object weight is not considered. This is one solution and this is another solution. Next, third solution, x of 1 to 6 is equal to, in the third solution, 12 and 18. First object is not considered. Second object is not considered. Third object is considered. Fourth not considered. Fifth not considered. And sixth we have to consider. Okay. So this is one solution, this is another solution, this is another solution. In this way, we have to find out the subsets whose sum is equal to capital M. So thank you for watching this video. If you like this video, please share this video to your friends and classmates. If you like this video, please subscribe my channel name. So DIVVELA SRINIVASA.